Hey guys, how are you doing? How is everything? We're going to carry on correcting the homework of speed, distance time graph. Okay, and as for page 51, it's about speed time graphs. So we get and we calculate the acceleration from speed time graph. Please watch out the difference because it is confusing for some. So distance time graph gives you the relationship between distance time, which is the speed, while speed time graphs gives you the relationship between speed and time, which is acceleration, right? So now the car speed changes. Let me just solve it in a draft. Okay, the car speed changes from 6 meters per second to 18 meters per second. Okay, so V velocity initial, which is the starting velocity, VI, is 6 meters per second, while V final, which is the final velocity the car reached, is 18 meters per second, right? And this change took a time of 2 seconds, right? Okay, to calculate the acceleration, it's a small, by the way. Okay, so A equals V final minus V initial and divided by time. So V final is 18, right? Minus 6 and divided by 2, right? So we get 12 divided by 2, which equals 6 meters per second square. Okay, now to answer the true or false question, the acceleration is 12 meters per second, so obviously it's false. Okay, meters per second square, so it's false. Now the first one, okay, while the second one is, there's no space, actually it's not going to match or to give some space for answering this question, so I'm going to answer it orally. A, B, and C are all false, okay, and only D is the only true answer, okay, as we have already calculated. Okay, so D is the only true one. Okay, now looking at the graphs, speed time graphs, diagrams A, B, C, and D. Now, which one is traveling at constant speed or shows an object which is traveling at constant speed? Now, let's take an example of diagram D, for example. Okay, now for diagram D, as the time passes, the speed is increasing, right? So this actually doesn't match a constant speed. However, it matches the acceleration. So we can write D here, right? Now let's speak about diagram C. Now, as the time passes, the speed remains the same. So this is the one for the first question, a constant speed. Now, diagram B, as the time passes, as you can see that the line is going down, so this means that the speed is decreasing, okay? So this is deceleration, okay? So this is B, the answer for the third question. Now for A, the line is going upwards, okay? And this is a straight line. So as the time passes, the speed is increasing as well. If even it doesn't pass from the origin, but this gives the same meaning that the speed is also increasing by time. So this is an acceleration. So question B has two answers, two possible answers, A and D. Right? Okay. Now describe what's happening to the motion of the bus between these 2 points. This is a bus journey speed time graph. Okay, again, I will need a draft to give me some space to answer the question. Okay, let me make it a little bit smaller. 1 second. All right, between O and A, what's happening here? Describe the motion. What is happening between O and A? So as the time passes, the straight line is going up. So the speed is increasing as the time passes. This means that there is acceleration, or you can say speeding up. That's also correct. Between A and B, as the time passes, the speed is not changing, so this means a constant speed, right? Okay, just need to make the box a little bit bigger. All right, however, from B to C, now the speed is decreasing with time, so this is deceleration, or you can simply say slowing down, right? And between C and D, as you can see that as the time passes, the speed is zero. Speed is zero means that the object is actually not moving, right? So you can simply say the bus stops. Okay, bus stops. Okay, very well. Okay, calculate the acceleration of the bus between the points D and E. Okay, obviously you have a certain section of the journey and you need to calculate the speed change throughout this section. Okay, so you need to just highlight a certain triangle here, which is DE, and we can just give here another point, which is X. Okay, right? This X is exactly between 21 and 20 and 22. So it's exactly at 21. Now, in order to calculate the speed at this part, okay, so this is the answer for question B. Speed, we do not need actually to calculate the speed, we need to calculate the acceleration. Okay, so the acceleration equals V final minus V initial, okay, over time, right? So what is V final here? What is the final velocity or the final speed the bus reached? Actually, it is at point E, right? In order to specify the velocity at this point, you need to draw a line from point E to intersect with the speed axis, right? You can find that it's simply between 4 and 6, so it's 5. So 5 minus V initial, the initial speed that the bus started with, which is actually at D. Now the bus was already not moving at this specific point, so the speed was actually 0, right? Divided by time. Now the time interval between the points D and E from 16 to the point 21. So by simple subtraction, 21 minus 16, you get 5. So 5 minus 0 divided by 5 is 1 meters per second square. Excuse me, because I don't want to waste the time putting the square on top, okay? Now for question C, let's calculate the acceleration and deceleration of the bus between points B and C. Okay, we're going to work this example exactly like before. So B and C, we just need to draw a second line to have a triangle, right? Okay, so B and C, okay, drawing another triangle. I don't know why it's not changing the color or the width. I'm sorry about this. Okay, so this is the triangle, which is BC and has a third vertex. Okay, now what is the acceleration here? So again, the same formula, A equals V final minus V initial divided by time. Okay, now what is the final velocity here? Is it at the point B or point C? Obviously, this is at C. The final velocity is at C. Okay, now the final velocity is actually at C, which is 0 because the bus already is not moving at this point. It's maybe the bus is at the station. Okay, so it's 0 minus V initial, which is the velocity or the speed at point B. Again, we need to draw another line to intersect the the y-axis, sorry. Okay, so from B, okay. What is the speed here? Okay, obviously it's 10. So 0 minus 10 and divided by time. What is the time interval taken to make this change? So simply we need to mention or to calculate the time difference. Okay, the time interval at this point, okay, which is 13 minus 10, which is actually 3. Now we get 10 minus 10, minus 10 divided by 3, so we get negative 3.33 meters per second square. And as it's shown here from the number, that if you have got a negative value for the acceleration, so this means that the object is slowing down. However, if you have a positive value for the acceleration, so you're speeding up, now you are accelerating. Okay, one more time. If you get the value for the acceleration in negative, so this means that the v final was less than the v initial, so this means that the object is slowing down. However, if you get the value of the acceleration with positive sign, this means that your v final or final velocity was more than the initial velocity, okay, and this means that the object is speeding up. So slowing down shows a negative sign, while speeding up shows a positive sign for the acceleration. All right, for the last question, as I have told you already, cancel question D, right? Here, for this question, the graph below shows Anya's journey home from school. Okay, now, and this graph shows some sections. Okay, how long does Anya stop at the playground? All right, let me just make the photo a little bit bigger. 1 second. Oh, that pretty well. Okay, how long does Anya stop at the playground? As you can see that she stops for some time, starting from the 5th minute and until the 15th, the minute number 15. Okay, so actually she stops from 5 to 15. This means that she actually stops for, yes, 10 minutes, right? Pretty easy. After they leave the shop, okay, because apparently she met her friends. Okay, so after they leave the shop, Anya and her friend go in different directions. How far have they walked together? So we have a section here which is mentioning that she meets her friend and they walk along. This is section, you can say that this is the one. Okay, this is a certain section. Okay, at which the girl is walking with her friend. So again, you need to use your ruler to specify the time and the distance. Now he's asking about how far, which is the distance. Okay, so you need to make another line here. Okay, the line for the distance. Okay, so the final point was at 1000 meters, while the initial point they started walking from was at 400 meters. Again, so they started walking from 400 meters and they reached 1000 meters. So they walked together apparently a distance of 1000 minus 400. So it is 600 meters. Right? Now, what's Anya's speed when she was walking with her friends? You already get the distance in answering question B and the time in question A. Okay, however, this time is irrelevant, but you need to have the time for the time at which the girls walk together. Okay, the time at which they walk together is actually from 15 to 25, which is actually also 10 minutes. Now we have the distance, which is 600 minutes, and the time, which is 10 minutes. You can simply divide them to get the speed. So speed equals distance over time. Okay, now the distance is 600 divided by the time is 10, okay, which is 60 meters per minute. Here we go. When they leave the shop, Anya realizes that she's too late, so she walks faster. what is her speed for the last part of the journey. Okay, so this is the last part of the journey. Okay, now you need to specify the distance and the time. Again, use your ruler. Specifying the distance, so you need to make a line to intersect the x-axis, two lines. So now you have a time which is from 30 to 40, so actually it's 10 minutes. However, the distance is 2000 in points, while it starts at 1000 again. So the total distance is only here, okay? The distance that the girl walked alone back to home is from 1000 to 2000. So it's only 2000 minus 1000, which gives you 1000, right? While the time she took in order to travel this distance back home is 40 minus 30. So you can simply calculate it through speed equals distance over time. Okay, the distance is 2000, right? Minus 1000 and divide 40 minus 30. Again, you get 1000, okay, divided by 10. So you get 100 meters per minute. That's simple. I just needed to show you how do we specify a certain part, a certain distance, or a certain time by subtracting the values. Okay, what is Anya's average speed for the whole walk home? You can just calculate the total distance divided by the total time. Okay, speed equals total distance divided total time equals, the total distance was 2000 divided by the total time was actually 40, equal, I think it is, 1 second, let me calculate it. So you get 50 meters per minute, right? And the last question for today, for a speed time graph, which section of the graph shows the cyclist accelerating? So accelerating means that he's speeding up. So it's obviously from 0 to A, right? As you can see that as the time passes, the line is going up, so the speed is increasing, so the object is accelerating, okay, or the cyclist is accelerating. Now, which section shows a cyclist decelerating? Okay, so obviously it's from B to C, right? Which section of the graph shows the cyclist moving at a steady speed? So obviously it is from A to B, and because as the time passes, the speed is not changing. Does the cyclist accelerate or decelerate more quickly? Okay, now the more the steepness of the line, the higher the speed. So actually he decelerates more quickly. Why? Because the steepness of the line BC is higher than the steepness of the line 0 to A. Now, how did you know? The steepness of the line, the steepness of line BC is more than that of the line 0A. 1 second. Alright, so now we're done. Thank you very much for being with me today, and study hard, and see you later. Bye.